Let us discuss about the feedback amplifier. Feedback concept. Feedback plays a very important role in electronic circuits. Parameters like input impedance, output impedance, voltage gain, current gain, bandwidth may be altered considerably by the use of feedback. In large signal amplifiers, the major problem of distortion should be avoided. Also, the gain must be independent of external factors. These are achieved by feedback. So what's the feedback? A portion of the output signal is taken from the output of the amplifier and is combined with the input to achieve feedback. There are two types of feedback. Depending upon the polarity of the signal being fed back into a circuit, feedback can be either negative or degenerative feedback, and the other one is positive or regenerative feedback. This is the general feedback structure. Vs is the input signal, Vi is the signal to the amplifier with gain capital A. V0 is the output voltage. The feedback network, the gain factor is represented by beta, and Vf is the feedback voltage. The parameters used in feedback amplifier are: A is the gain of the basic amplifier, beta is the feedback ratio, that is Vf by V0. AF is the gain of the feedback amplifier and V0 by Vs, where V0 is the output voltage and Vs is the input signal. Let us see about the positive feedback. Positive feedback occurs when the feedback signal Vf is in phase with the input signal. That is, Vi is equal to Vs plus Vf. Second point is, it will increase the input signal to the amplifier, thereby increasing the output. The gain of the amplifier is given by V0 by Vs. That's equal to V0 by Vi minus Vf, since Vs is equal to Vi minus Vf from the structure diagram. Finally, AF is equal to A by 1 minus A beta. Inference. Thus, we understand that if the loop gain A beta is equal to 1, then AF is equal to infinity. The advantage of positive feedback is gain of an amplifier increases. There are some drawbacks in positive feedback. One is drives the circuit into oscillation. Second one is it leads to instability. And finally, it affects the performance of the amplifier. Thus, positive feedback should be avoided in amplifier. It can be used in oscillators. Second type is negative feedback. Negative feedback occurs when the feedback signal is out of phase with the input signal. That is, Vi is equal to Vs minus Vf. Now, the gain of the amplifier becomes AF is equal to V0 by Vs. Since Vs is equal to Vi plus Vf, final equation is AF is equal to A by 1 plus A beta. Now we can understand that if the loop gain A beta is very much greater than 1, the above equation is reduced to AF is equal to 1 by beta. Thus, the gain depends on the feedback network, which makes the amplifier stable. There are some features of negative feedback. One is they desensitize the gain. That is, the gain may change due to some external factors like temperature variations, aging of components, voltage fluctuation, etc. The value of the gain is made less sensitive to the above variations by achieving feedback. Next feature is it reduces non-linear distortion. That means the output is made proportional to the input. We can easily understand from the diagram. The curve A represents without feedback and B represents the gain curve for with feedback. It is almost linear. That means the output is made proportional to the input. Thus, it reduces non-linear distortion. Next feature is it reduces the effect of noise. Next, it controls the input and output impedance. That means the input and output impedances are increased or reduced by the selection of appropriate amplifier. Last feature is it extends the bandwidth of the amplifier. from the diagram, capital B represents the bandwidth curve for without feedback and BF represents the bandwidth curve with feedback. That means the bandwidth of the amplifier gets extended. The drawback of the negative amplifier is the gain of the amplifier gets reduced. So we consolidated all the points and can give, if there is no feedback, A is equal to V naught by Vs. With feedback, AF is equal to A by 1 plus beta, where A is open loop gain of the amplifier and AF is closed loop gain of the amplifier. And friends, overall we can understand that if AB is very much greater than 1, then AF is equal to 1 by beta. That means the gain with feedback is independent of the open loop gain capital A, depends on only the feedback factor, thus maintaining the gain highly stable.